So we're going to be reading chapters 8 and 9. Chapter 8, Nematodes. Nematodes are non-segmented, blind roundworms that, along with protozoa, mineralize nutrients contained in bacteria and fungi. Their name is derived from the Greek nema, which means thread, an apt descriptor for these microorganisms. Nematodes are considerably larger than protozoa, with lengths averaging 2 millimeters and diameters of 50 micrometers versus 0.5 millimeter for a decent-sized protozoan. Still, most nematodes are difficult to see without a microscope. When you can see them with the naked eye, they usually look like moving human hairs. We say usually because the largest known nematode, Placentanema gigantissima, can grow to a show-stopping 30 feet, 9 meters. Damn. Fortunately, this nematode lives in the placenta of sperm whales, not in the soil. These fascinating roundworms are actually the second most dominant form of animal life next to the arthropods. Over 20,000 species of nematodes have been identified thus far, and scientists suggest there may be as many as 1 million species in total. They are everywhere, yet most gardeners know little about them, save the parasitic ones that damage roots. Yeah, 30-foot nematode inside a sperm whale, huh? Holy Moses. Yeah. Our teaspoon of good soil teeming with microbial life averages about 20 bacteria-eating nematodes, 20 fungal feeders, and a few predatory and plant-eating nematodes, making the total number between 40 to 50 nematodes. The number of fungi versus bacteria-eating nematodes is directly related to the availability of the food sources they require. Picky eaters. Nematodes are major consumers in the soil. All have a long alimentary tract that runs from the mouth to the anus, which is located in their tail end. Nematode skin is actually a cuticle. It protects the animal from both physical and chemical attack and provides lightweight structural support. For the gardener, the best way to classify them is by their eating habits. Various nematodes have developed specialized mouthparts to allow them to attack and get their own particular brand of prey. Yeah. Notably, the fungi protects itself with chitin. The bacteria is covered in a biofilm. These different nematodes develop the specialized mouthparts to get around and about its prey. Same thing with the ones that are eating other nematodes and the ones that are consuming the plants. They're able to develop specialized mouthparts that are strong enough to chew through the cellulose and the lignin and stuff. Yeah. Let's start with the nematodes that eat living plant material. These plant parasites usually have needle-like stylets that enable them to puncture plant cell walls with ease. Some of these root-eating nematodes are ectoparasitic. That means they feed on the root surface, while others are endoparasitic, entering into the root to feed. Herbivore, plant-eating nematodes can create lesions in the root as well as cysts and large bulges that gardeners refer to as root knots. Obviously, nematodes that eat roots do not help the crop in question. Next are bacterivores, nematodes that eat bacteria. Here, the specialized mouthpart is usually a hollow tube. A bacteria-eating nematode so equipped can consume multitudes of tiny bacteria in an hour. Other nematodes are fungivores. They eat fungi. Yeah. This type of nematode also has stylets for puncturing the chitin cell walls of fungal hyphae. Like their fellow fertilizer spreaders, protozoa, both these types of nematodes mineralize the nutrients contained in the smaller microbes' bodies, making them once again plant available. Predator nematodes feed on protozoa, algae, including diatoms, and other small members of the soil food web, grubs, weevils, wasps, even small invertebrates, such as slugs. The first beneficial nematode sold for gardening use was to control slugs. Predatory nematodes eat other nematodes as well, thus preventing overgrazing of bacteria and fungi and keeping populations of destructive nematodes, primarily the herbivores, down. As with protozoa grazing on bacteria, fungal grazing by nematodes frees up fungal food resources to such an extent that fungal populations are increased to a point, resulting in increased decay of organic litter. Thus, nematodes are indirectly responsible for some of the decay that occurs in and on the soil. Other nematodes are omnivores, eating any and all of the above, to the merest fungus spore. Some even ingest organic matter, and so are directly responsible for the decomposition of organic matter. Mineralization and other tricks. Arguably, mineralization is the most important thing nematodes, at least bacteriivores and fungivores, do for gardeners. Nematodes need less nitrogen than protozoa do, those that eat fungi and bacteria, therefore release even more of the previously immobilized nitrogen into the rhizosphere in ammonia form. Again, if the populations of nitrogen-fixing bacteria in the area are low, as they will be when the pH is below 7, the mineralized nitrogen remains predominantly in ammonium form. That is, it is not converted to nitrate. But here's something new. Because nematodes are bigger than bacteria, fungi, and protozoa, they require more porous soils in which to travel, and their numbers will be reduced if the soil is of the wrong texture or if it is too compacted. Either of these conditions will block nematodes from searching for nutrients. Unable to search for food, they either die off or move elsewhere, and the flow of nitrogen available to plants is greatly diminished. Not just these escapees, but all nematodes inadvertently play a role in transporting bacteria to areas far from their origin. This is because bacteria attach to the skin of nematodes and are spread to other areas as the nematode makes its way through the soil in search of food. Since bacteria themselves have extremely low mobility in the soil, this is a great advantage to them. They can taxi to new food sources. It also may be said to help the nematode, who in the long run occasionally eats the progeny of its fare and increases mineralization in a new area. Fungi too can hitch a ride on a nematode. Often this is because the hapless nematode is prey to a fungus attack and goes about its business while it's being eaten alive. Nematodes have developed some interesting ways to locate food in the soil. They may have specialized mouth parts, but they do not have eyes. How does a blind nematode survive in the soil or anywhere else for that matter? Some nematodes can sense extremely minute variations in soil temperatures. They know what temperatures particular food sources live in. They will move through soil until they find the right temperature gradient and continue to travel along until they bump into their preferred food. Others find food by sensing particular chemicals associated with them. Once they are on the scent, they act like heat-seeking missiles, locking in on their prey and attacking. Our favorite fungus, the one that captures nematodes in its rings, attracts nematodes with a chemical. Clearly, there are dis- clearly there are disadvantages to this method of finding food. In the end, nematodes are incredibly diverse and interesting animals that, like each and every other organism in the soil food web, deserve and have their own books. Oh yes. That was chapter 8 so far. Yep. We're actually reading the book on all of this, and to be honest, what you just stated is incorrect. We were talking about the balance in the soil food web and having this balance. Too much of a good thing is a bad thing as well. We were just talking about that where these different there's the fungi, the bacteria, the archaea. Um, those are going about doing their thing. Then they're being consumed by the different protozoa, the ciliates, the flagellates, microarthropods. Those are in turn being regulated by different nematodes, and that's dependent also on your soil base, the soil chemistry as well, the content of your soil, the variation between what was it? Clay, silt, sand, the organic matter within your soil, the ratio of that. That'll determine, some have smaller pores within the soil in which certain microorganisms can hide and thrive when they're being cold and regulated by other forms of microorganisms that are consuming them and stuff. Yeah. Yeah, I wouldn't necessarily if they're selling nematodes to battle slugs, I wouldn't go off and say not to do that because it's just part of it. Yeah. If you have a healthy soil food web and you incorporate those microorganisms, it should even itself out. The different populations will consume their prey, and then once that prey is short on hand, then some start to turn on each other and recultivate. And we were talking about that there, about the pores in the soil where different organisms can survive. They will go to these outlets and propagate once again and continue. And so there's nothing wrong with that. Oh man, he just redeemed the generation joint too. Alright, yeah, I will definitely get down on that right now. For shizzle. Yeah. The balance. It's that, so they were talking about that, about the spoonful of soil, and each chapter we go through and talk about the different things that are in the soil. Like I said, the fungi, the bacteria, the archaea, oh gosh, I don't even know if the bioslime would be considered in that. I wasn't paying attention if that was described in the spoonful of soil, but you still got the other populations of the bacteria eating nematodes, fungi eating nematodes, plant eating nematodes, and oh gosh, sorry, cannibalistic ones. Yeah. Yeah. I don't care if you read the book or not. Your attitude is piss poor, man. Like really, I just asked you to relax on your thought process there. You were kind of sharing the inside thoughts on the outside, and it's kind of hard to just kind of hang out and communicate with that. I love to try and sit here and talk about the facts and the science as we're trying to learn. There are folks that are on different levels, and there's nothing wrong with that. I never said that I'm a know-it-all or on a certain level. I just rather would discuss with the room the facts and the science and try and have a meaningful conversation as I kind of communicate with people, and this occurs, Like you got upset because I told you to calm down and you said, okay, bye, and then you still hung out in the room and listened to me and all this and stuff. That's some stuff you got to work on with the socializing, please, for sure. It makes me uncomfortable. Yeah. it makes me uncomfortable when folks do that. It would make anyone uncomfortable, when it's like that, So please, yeah. There are lots of folks that haven't read the book. We're all reading together and learning and stuff as well. Yeah. But I'm just a simple gardener. If you can't sit there and have a discussion about what you know and just explain it in detail and stuff, it's not really like having a conversation and trying to explain and teach and learn from each other. It's more so just trying to like whip it out and see whose brain's bigger, And that's where it gets sometimes when we have these conversations, and like, I'm always sitting here trying to educate and talk to folks and explain these ideas that we're learning about, not just throw out terminology, So like a lot of folks look to me to have a conversation, and that's what I get back. Like I have full explanations and details and try and learn from others as well, and it's difficult as I get folks that just kind of come out there with vague explanations and terminology with no explanation and stuff, It doesn't help. I'm sitting here and I want to have the conversation and like we could talk about stuff, but if you really can't explain further what you're explaining, without like telling us to Google it or not even explaining anything, it's hard to take on that information just in general. Not saying I don't believe you, I just like I love to hear folks explain stuff and then like explain it in their own terms, because it helps us understand that you know what you're talking about as well. Nobody likes a Weisenheimer. Yeah. Girls are maturing, growing long hairs on the stalk. Yeah, what is? I mean, we're also adults, and there's just a lot of stuff that people know but don't know. I don't know. I'm trying to keep an open mind. Yeah. Oh yeah, it's so cool. Yeah, all over, dude. Like there's this thing where there's like oh yeah, the diversity in those, like they were saying in that chapter, there's like over a freaking possibly 1 million species of nematodes, and then the one that's in the gut, right? It's crazy to think about these ideas. Like I was talking the other day about the archaea. The archaea is an extremophile, relative to bacteria, but it's one that thrives in environments that are inhabitable to other forms of life, where there is no oxygen and stuff. I keep looking back to it, it's like, so you got this archaea, doesn't survive in oxygen, doesn't do very well there. They've noted on it because they were able to find it in places like those thermal vents underwater, under the ice in Russia, deep underground. The geysers at Yellowstone National Park, volcanoes themselves like Mount St. Helens and shit. They were able to identify that by looking at those examples, but they also learned that shit's there in the soil and cohabitating in us, in our gut, with the other bacteria. And all of these things like have a purpose, and like, we read about them and look at them separately, and you see the bad ones that they talk about. It's like, well, it's the cohabitation, the relationship, the symbiosis with some of these things sometimes, Like, I've always had this fascination with lichen. I've really enjoyed it because it was like one of those terrestrial forms of algae that you don't find near water, just in places that have higher moisture content. And reading the book, I was like, oh well, lichen is the symbiotic relationship between fungus and alga, green algae, um, so that it could grow on this rock and fucking remove the minerals from the rock. I always thought it was just hanging out and like doing something like producing oxygen or something. I don't know. I didn't know. And it turns out that it's just literally just sitting there, just taking over the rock and consuming it slowly over time and turning it into soil and minerals for the soil and stuff. It's fucking crazy, you know. So like, yeah, just slowly over time, this algae and fungus in a symbiotic relationship is doing its thing to just take over rocks and cut into them and stuff. It's eating rocks, yeah. Like I'm in the desert where we don't see that very often because it's a drier, hotter climate, so you won't see the presence of algae or lichen like that in places unless it's somewhere where there's less light and energy and higher humidity because it's closer to a water source. And oh, so it's crazy. I see the water and the wind cut into stone, and that's very different compared to what transpires when you've got this lichen taking over and doing the thing. That's crazy. I'm doing pretty good, Shotgun. Thank you. I was very curious about lichen as I found a Life Science article that was talking about how they've been looking into how old these microorganisms can live. You know, some of them will straight up go dormant and just continue as the environment gets better. More habitable for those organisms, you know? And one of the ways they've been able to identify how old lichen is by looking at fucking old tombstones from like the 1800s and 1700s and beyond, you know? It's pretty crazy. They've been able to just like take those samples and be like, well, this is what's going down. I've like seen that part, but it wasn't until this year and reading the book that I had understood what the lichen was and what it's actually doing to the stone and shit. Science, right? Okay, I'm in the process getting this Jenny going. Mm-hmm. Oh. Sorry, I'm rolling up a generation joint. We're having a little talk. I'm also going to read chapter 9 as soon as I roll up this generation joint. Thank you for hearing me out and in the book. I will try my damnedest to answer questions when we can. If someone could, I'd really appreciate it if we type the exclamation point genuine command in chat as I try and express this with folks. I don't want to be a know-it-all or sit there and tell you this is how it is with ideas and stuff, you know, and like just kind of just blabber and rant in a way that it just doesn't make sense. Please. If I'm ever there, say something. If I need to reiterate, if I need to clarify, and I tell you like, hey, there's some info, you can go check it out, it's probably somewhere else as well that can explain what I'm talking about further, you know. Thank you, man. Yeah. Genuine friendship and community, peer-to-peer review, insight, and education. To separate facts from opinion. I think I'm going to add something to that. To separate facts from opinions and ideas. You're more than welcome to share your experiences, but don't be vague and demanding, okay? No worries, there ain't nothing wrong with that. She hit it twice to fucking hit home, you know? Drive the point home. I have had a lot of people get upsetty spaghetti because they want to express ideas, and this is a place that's cool to talk about. I always love hearing about people's projects and their different thing and their own manner of growing and gardening and background with it. But like, damn. Sometimes it can get to a point where it's like we gotta really be mindful about what we're saying to the group, because there are people here that are listening into what we talk about, and they start following routes, and sometimes it's not the right one for them, you know. So I try to stick to the point with our discussions when we're like learning about something, actually learning, and have a conversation about it and stuff. Like, oh gosh, my man Yoshi has been sharing with me a lot of information in regards to his like automated setup and how concentrates are processed. To which I have never looked into any of that kind of stuff, but like, oh man, he talks about it all the time. But this dude is fucking hitting me up with like a healthy amount of information on top, you know. Shit. And it's something where it's like, it's really cool taking it in and looking at all this, and I'm like, it's really cool to have a discussion with somebody and see their perspective and experience and education with it, like what they know about it, because I don't know it all. I don't know shit. That's why I'm reading the book, you know. Fuck yeah. You gotta do it in front of the other seeds that you plant so that you put them in line. They know to grow to be the best, thinking that they're going to survive, outlive the rest, you know? In the end, they all go through the butcher's kitchen. Alright. Right? Oh boy. That shit's always funny. There's always one. I gotta groom my shit because I feel like that's gonna happen to me, but I don't know. We shall see. Today is day 9 of flower cycle, and yep. Yeah. I grinded up the cannabis. I'm working with it right here. I don't have a close-up cam right now. I got a set up so I could do that. I think I gotta go and purchase like a green floor mat. I think that's the best route to go. Like, get like the foam mats that are like puzzle pieces that you can put together, and just lay that out on the floor when I'm doing stuff, and I could just have like green screen all over. Oh my. I am very excited, man. I was freaking out for a little bit as like, you know, I've done some changes. Like, this is the first time I've like dedicated like fed plants every day. Like, I normally grow my veg plants and wait until they're thirsty as fuck to water. And then I'm doing the drain to waste with this one. Understanding what I know now about how plants will intake and catch what they can when you top feed versus live soil where supplements, chemicals are trapped within the microorganisms, immobilized, and then released once they're consumed by other fertilizer spreader microorganisms. Blah, blah, blah. Consumed and spread by other fertilizer spreading organisms. Sorry. Shit like that is crazy. So I was more comfortable. Like, at first I was like, dude, am I gonna overwater? And I was like, no, water, let them drain through. It will capture what it wants in your feeding, and just keep going. And it's been fine. I've been trying to make sure that, yeah. Oh yeah, I'm doing one more round, day 14 of that. Final defoliation. I think I said final defoliation like two weeks ago or something, but this is it. Like I was giving them the bloom food and increasing the feeding, and they've responded. They're happy with it. So I'm continuing that regimen that I've introduced, and they're still like I was like, oh well, I think this will be okay to grow, and then I seen everything else stretch and spread out. It's like, holy shit, there's just so much growth happening right now. Yeah, I'm eager to see the what comes out of it from how I've topped it so much. It's a totally different style from lollipopping and stuff. You know, I have a handful of branches that'll shoot up, maybe like 4 or 5 nice colas off of a little branch, and they just make little spears, and so this is different. Hmm. Yeah. Okay, I got the generation joined here. So sorry. I was preparing this shit. Yes. Testing runoff is very important. I haven't done that yet here. I haven't seen signs of deficiency yet, so I haven't gone there. Um, yeah, it is totally. So the key with that is to make sure that it's completely running through, not just channeling, because sometimes you'll water, and some folks will see water run through one of the four or one of the multiple drain holes and think that's a-okay, but that's probably just water channeling and leaching down a portion of the soil base versus the entirety of the soil base. And through what we were learning in the book about fresh feedings, not only are you introducing clean, fresh oxygen, you're pushing out pockets of older oxygen as well. So that was something that was key. Yeah, a little harder to maintain if the ratio isn't ideal. Absolutely, it could be tougher. And there's like something. What is it? What is it when you do that? Like, is it harder for it to stay at a higher pH? Does it lower, or does the pH spike? I don't think that's a thing. I don't know. I've seen that a lot with folks. Like the last example was a friend of ours here that was running DWC, and he put molasses in his feed in his reservoir, and the presence of that lowered the pH to like 4 pH. I was like, oh damn, yeah. Yeah. I was wondering at that point if it was too much and if the plant wasn't taking in what it wanted and it was just lingering in the running water and just kind of just changing the chemistry. Like that with like I was talking about top feed with the watering, the plant's only going to take um, yep, molasses lower the pH being present in the water or not being intake. Yep, because the plant is putting out exudates, which are the sugars. Yep. Yeah, so it was one of those that just in that instance it might have been too much to add um, the molasses into his reservoir. It just lingered because the plant's like, nah, the stuff's not present to really work with it, uh, break it down, convert it, recycle it into something that the plant will intake too. Um, so it just kind of hung out, and and changed the chemistry. Makes sense. Yeah. Yeah, that was an Instagram post from our dude here. I had seen. He's finishing his plants off. He's like flushing them and stuff. So he was running water and then molasses on it. If res was bigger or he used less, it probably would have been good, right? Yeah, for sure. And that was something. I think it was an instance where it was like an overnighter thing. He did it and then like came back the next day and had checked on it sooner to see the gradual change within a 24-hour period. You know, dramatic change. Sorry, that's I don't know. That's about on par. Some shit happens quickly. Some shit fucks up quickly. But I think that's okay. Cheers, Reaper. Yep. Oh, totally. Yeah, that's the way of the body of water, bro. That's the shit. It's so funny. They teach us that when you do um, the courses for a certified pool operator. They teach you to alter the chemistry of based off of the saturation index, so that you could either reduce the chlorine content or reduce the chloramines in the water, decrease the pH, how we would use the acid and bleach in combo to make a righteous saline salt pool. But it's similar to that. They're like, all right, so here's what you do to make it right. But if all else fails, just drain the motherfucker and start over. And it's the same shit with DWC, right? It's like, yeah, just drain the motherfucker and start over fresh. Yeah. Yeah. The closest I've come is a live pool. I treated a live body of water so that we could raise koi, and there were plants in the area that helped filtrate the water. But I was not at the level where I could understand what was actually happening. I was only at the level where I was receiving training to understand the process of testing and implement testing to understand what's going on there. Not actually learning the concepts of like what we're learning now about like relationships between microorganisms in the soil, the water, the plants, um, archaea, bacteria, and the eukaryotes. The bacteria, the archaea, the eukaryotes. I believe the fungi are eukaryotes too. Um, Fungi, plants, animals, people. We're eukaryotes on the tree of life. Yeah. Um, what's like? So I have this question, like for like a DWC failsafe kind of thing. So if you have a DWC system and you're running on a pump, and the pump fails, but you still have like electric connection, like, would it be optimal to have like an air stone in conjunction so that at least if the flow rate is decreasing, you still have oxygen being produced and keeping the water from going completely stagnant and fucking up the chemistry? Sorry, I'm high. Well, yeah, that's the thing. Is like, oh, not long. That's one of those. That's also one of those things that goes on the shelf where it can go to shit quickly, quicker than you can repair it. So like one of those that could be a something that is one of those 24-hour issues where it's like you check on your system, you don't come back until a 24-hour period. Within that 24-hour period, it can affect it in some manner. Maybe not extremely detrimental, but you'll definitely see at that point like oh gosh, the plant will probably either get waterlogged or just lock up. It just won't want some of that stuff because it's just not right for it anymore. Oh yeah, right. The plant will wick and take it in, and then pump out the excess. It'll just be kind of essentially going from circulating air with oxygen to lack of oxygen and circulating water. Then it becomes like a toilet. Alright. Thought-provoking discussion. Thank you for that. I'm going to get back into the book before we have any further discussion, if you do not mind. Alright. Teeming with Microbes, Revised Edition, by Jeff Lowenfells and Wayne Lewis. Chapter 9, Arthropods. Even if you didn't know what they were called, you've seen and know lots of arthropods. Flies, beetles, and spiders, for example. No exaggeration, arthropods rule the world. Somewhere around 3/4 of all living organisms are arthropods. Still, for all their numbers and their larger size, the arthropods do not lead in terms of biomass. The biomass of nematodes and even protozoa is greater. Arthropod is Greek for segmented feet. Actually, arthropods possess segmented limbs and segmented bodies, but you get the idea. In addition to jointed legs and segmented bodies, all arthropods have in common an exoskeleton made from chitin, the same material that makes up the walls of fungus cells. You are familiar with the shells of lobsters, shrimps, and crabs, familiar examples of marine arthropods. Their shells are chitin. As with the cuticle skin of nematodes, their exoskeleton provides protection and a lightweight structural frame. An internal skeleton is considerably more complicated and heavier. As arthropods grow, they shed their exoskeleton and grow a new, larger one. Arthropods usually have three, but may have only two body segments, starting with a head or cephalum, then a chest or thorax, and finally an abdomen. Most arthropods live life in three stages. They start as eggs, hatch, and live the early part of their lives in a larval form, and then metamorphose into a very different form for their adult lives. Let me reread that. They start as eggs, hatch and live the early part of their lives in a larval form, and then metamorphose into a very different form for their adult lives. A caterpillar, to use one famous example, is the larval stage of a butterfly, the adult who will lay eggs and start the cycle over again. Many arthropods live all three stages in or on the soil, but many reside there during just one or two. Of course, any gardener who has fended off cutworms fully appreciates that it takes only one stage to damage a plant. Arthropods range in size from the humongous Alaskan king crabs that measure a couple of yards across to tiny mites that require a powerful microscope to see. Those that can be seen only under magnification are classified as microarthropods. Those that can be seen easily without the aid of a hand lens or microscope are known as macroarthropods. Besides being food for other members of the soil food web. Oh, thank you for that subscription. This is not a drill. I hope you're doing well today, Sunrise. That's super awesome. 20 months. Thank you for the continued support. All right, let me go with this again. Besides being food for other members of the soil food web, soil arthropods are important to the community as shredders, predators, and soil aerators. The presence or absence of certain of these key players can tell a gardener much about the health of soils and the plants growing in them. Oh yeah, dab time. Get you some. Classifying arthropods. Without more than a passing interest in them, most gardeners lump all their arthropods together as simply insects or bugs. Any given gardener may know a few of the popular and unpopular ones that inhabit local gardens, but for the most part, not many more. Part of the problem is that there are too many arthropods. The phylum, Arthropoda, is by far the largest in the animal kingdom, so large that it presents a real challenge for us. How can we, the authors, show you, the readers, how to use the soil food web without overwhelming you with information? There are just too many kinds of soil-dwelling arthropods to describe them all, or even come close to doing so. And frankly, there is too much scientific nomenclature as well. Bear with us for the little we do use. Gardeners agreed that using scientific names, usually derived from Latin or Greek, is truly the only way to accurately identify a plant. But most have not learned the alphabet soup of words scientists use to classify members of the phylum Arthropoda, whose members have the greatest impact on the soil food web. Here, we list the classes as a start. Oh, my Lanta. Yeah. So, they've got this huge descriptor of all of these different arthropods, class arachnida, spiders, scorpions, mites, ticks, and daddy long legs, chilopoda, centipedes, diplopoda, millipedes, class insecta, springtails, silverfish, termites, mayflies, dragonflies, damselflies, stoneflies, earwigs, mantids, cockroaches, walking sticks, grasshoppers, katydids, crickets, rock crawlers, web spinners, Zaraptorans, and what the hell? Sosids? Book lice, bark lice, chewing lice, sucking lice, scorpion flies, fleas, thrips, lacewings, antlions, true bugs, moths, butterflies, flies, beetles, sawflies, bees, wasps, and ants. Then there's the Malacostraca, sow bugs and pill bugs. You're already familiar with many members of the class Insecta. Tens of thousands of different kinds of insects live in and on the soil and plants, as few gardeners need to be reminded. Yo.
We'll get a shot.
Alright, sounds good. Surely you have seen representatives of one order of this one class. The order Coleoptera. Beetles. As you go about gardening chores, with approximately 290,000 species described, it would be hard to miss them. Soil food web functions. Most soil arthropods, particularly those that reside on the soil surface, are shredders. They chew up organic matter in their constant quest for food, creating smaller pieces. As a result, fungal and bacterial activity is increased because shredding exposes surfaces on organic litter that give bacteria and fungi an easier avenue of attack. As they shred and move about, arthropods also taxi microbial life, attached to their bodies or in the debris they push off or carry about. Since most arthropods are food for still larger animals, the total distances microbes can be moved. Consider a bacteria colony eaten by a grub that is then ingested by a robin, can truly be great. Microbial activity is increased if the taxi takes its fare to a good food source. Still, it is the shredding that is most important. Two common arthropods, mites and springtails, are alone responsible for recycling up to 30% of the leaves and woody debris deposited on a temperate zone forest floor. Let me reread that. Two common arthropods, mites and springtails, are alone responsible for recycling up to 30% of the leaves and woody debris deposited on a temperate zone forest floor. In the face of insufficient dead organic matter, arthropods often attack living sources of organic nutrients. And even if the supply of available organic matter is abundant enough to satisfy any reasonable arthropod, some mole crickets, root maggots, cicadas subsist on roots anyhow. Fungus gnat larvae, for example, hatch and immediately start eating root hairs, eventually eating away into the roots and stem to the great detriment of the invaded plant. Still, other arthropods eat other members of the soil food web in order to survive. By removing their fellows, these predator arthropods make room for other arthropods to fill the emptied niche, helping to create complete digestion of soil matter. Finally, in much the same way protozoa and nematodes do, some arthropods eat fungi, others bacteria, but this time releasing nutrients on larger scale, befitting their greater numbers in size. Many arthropods carry out their daily routines only on the surface of the soil. A surprising number, however, live at least part-time below the soil surface. As these arthropods go about their business, they mix and aerate soil, their waste products also add organic matter. Mites. Several soil arthropods play dominant roles in the soil food web. Among them are mites, of which there are two basic kinds in the soil. The first, Oribitid mites, actually have the highest populations of any soil arthropod, with up to several 100,000 per square yard. A primary reason for this is that the female Oribitid mite doesn't need a mate to lay fertilized eggs. These important mites are 0.2 to 1 millimeter long. Oribitid mites inhabit soil surfaces, particularly litter debris, but also live plants, including molasses and lichens. Some Oribitid mites feed on live nematodes, others on dead springtails. Most, however, eat fungi and algae and decaying plant matter, and because of their large numbers, are major recyclers and decomposers in the soil food web. Although they are vulnerable when they are born and in the later nymph stage, as adults, their exoskeletons make these mites impervious to most forms of predation, except by ants, beetles, and larger animals like salamanders. The second kind of soil mites, gamacid mites, are major predators in the soil. Their population, and there could be several hundred gamacid mites in a square yard of soil, are dependent on the availability of their food source, which happens to be most any other arthropod that grazes in the soil. As such, the presence and numbers of gamacid mites are considered useful tools in determining soil health. If there are lots of them, their fellows must be plentiful, and that usually means a healthy soil food web. Soft-bodied for an arthropod, they fare less well than Oribitid mites against predators, however, and are themselves prey to all sorts of other arthropods. Most gamacid mites act in a manner reminiscent of spiders, with whom they are often confused. All mites, like spiders, have 8 legs. They inject their victims with enzymes that dissolve their innards and turn them into a liquid that mites then suck. Gamacids subsist of collembolans, insect larvae, and insect eggs. Collembolans? Those that live in the soil, as opposed to on its surface, also eat nematodes and fungi. Springtails. The springtails, another important group of arthropods, are among the more active insects in the soil. You can expect to find up to 100 of these soil fleas per square inch in soils with enough organic material. Ranging from 0.2 to 2 millimeters long, they are often seen as little critters that jump into the air when the top layer of soil debris is disturbed. Springtails lack wings. Instead, they possess a forked tail, or furcula, that folds beneath them, but is capable of being straightened in an instant. Fluid pours into its base, propelling the animal up to a yard backward, hence their common name, out of harm's way. As with many members of the soil community, springtails have adapted to several different kinds of environments. Those dwelling on the surface, for example, have well-developed furculas, eyes, long legs, and antennae, while those that dwell in deeper parts of the soil are blind or near blind and don't need a large furcula or long legs, as these would be hindrances in traveling about in search of food. Some springtails, with even more developed springing tails, are especially adapted to live among grasses. A springtail's diet consists of bacteria, fungi, and decaying organic matter. Springtails are also sometimes consumers of nematodes and dead animal matter, and are themselves the favorite food of mites. Termites and ants. Two other abundantly represented members of the soil food web, termites and ants, are not really related, even though they look similar. Ants are related to bees and wasps. They usually have eyes, opaque bodies, a narrow waist, long legs, and a hard exoskeleton. Termites, by contrast, are blind and have soft, translucent bodies and short legs. The shredding activity of both these insects helps decompose organic matter on the soil surface. Termites eat mostly materials containing cellulose, as do other arthropods. They open up organic matter, making it easier for fungi and bacteria to get at it. Some of this organic matter is brought down into tunnels and burrows where it becomes available to different populations of microbes. Indeed, it is the construction of tunnels and mounds that distinguish both termites and ants from other microarthropods. In constructing their homes, ants and termites make surface and subsurface soil. In the case of ants, up to 6 tons of soil may be mixed a year. In tropical areas, the contribution ant and termite activity makes to the mixing of soil is greater than that of worms. Ant and termite tunnels obviously provide a way for air and water to get into the soil, and for other animals to move about. Sometimes these tunnels make it easier for roots to penetrate the soil. Often, roots will follow tunnels. Termite and ant mounds, formed on the surface of soil, contain subsurface material, and as these mounds are weathered and break apart, they alter the surface soil mix. Finally, termite hindguts contain methanogenic archaea that produce methane. So much that termites are a major contributor of this greenhouse gas to the atmosphere. In sum, because of their huge numbers and the varied jobs they perform, micro and macro arthropods are crucial to any functioning soil food web, and their presence, both in numbers and kind, is an indication that the community is not only working, but healthy and thriving. Chapter 9. Arthropods. Very cool. So we learned a little bit more today about nematodes, the different kinds of nematodes in the soil, the arthropods, microarthropods, macroarthropods, some very interesting things that I love to mention, just based off of observation and idea that there's fucking science that goes behind that, you know. As a gardener, for over 10 years I've been messing with plants of all sorts beyond cannabis. And something that is a major problem out here for us in the desert is when an ant colony will try to use your potted soil as an anthill versus actually going into the earth that's totally dead and dry. So they'll seek out that, like, the moisture, the things that are within the soil, and like thrive in that environment. So here we would have those critters that would try and invade the soil base through drain holes of potted plants. I would always tell people, like, this is a manner in which you would get non-beneficial microorganisms to the insects, those arthropods, the ants and stuff. These microorganisms are like fleas to them, just things little clinging here and there. they had mentioned it a few times between the nematodes and the arthropods that they are what they would consider taxis for microorganisms as well, where not only are they in the soil consuming certain things, so like an example, um, you could see a nematode that's consuming bacteria and it's going for that. And so you've got some fungi or bioslime or something else that it had gone through and around, and it just kind of catches on and it's traveling, going to different parts of the soil, and those different microorganisms end up hitching a ride and are carried to other parts where they wouldn't be able to travel naturally so quickly. Um, so that was really cool. Like, we're trying to understand that they all play key roles, and they have these different relationships directly and indirectly. Like I was saying about the nematodes and the arthropods, like the ants going into the potted soil, into the potted plant soil base, and not only fucking it up by being present in the soil and trying to colonize, but also carrying non-beneficial microorganisms, some beneficial, but it's really dependent on the environment and how healthy it is around you and stuff. The presence of certain arthropods, macroarthropods, it was talking about a few in the end there, like the springtails and mites, the population, and yeah, the type of these arthropods and the population is a key indicator for the health of your soil. That's something like we always look to, having all of these different things present within the soil to identify, not just the bacteria and the fungi. There's the whole soil food web, like we talked about, and so far we've covered a little explanation through the book. Bacteria, archaea, eukaryotes, the fungi. I already said that. Sorry. Arthropods, microarthropods, the protozoa, ciliates, flagellates, the nematodes, everything going up beyond, worms, grubs, mites, ants, spiders. They all are doing different things in the soil. They're, like I said, relationships directly, indirectly. You've got these different grubs traveling through the soil, aerating the soil. They're consuming the bacteria, fungi, decomposing organic matter, converting it into different things. Available ammonium into nitrates, and that's being immobilized by the bacteria and the fungi and stuff. And then those are being consumed by the arthropods and the microarthropods and the protozoa. They're not eating all of them because there's different types of bacteria and fungi, and there's different types of these protozoa and the nematodes that go after certain species of these microorganisms, the bacteria or the fungi, or going after the plant, or going after other species of themselves, of the microarthropods or the nematodes. With the nematodes today, we had talked about that there's the ones that are going after bacteria, ones that are going after fungi, ones that go after the plants, ones that go after each other, omnivores. They just eat everything, And it's one of those things where, we talk about these situations where there is a lack of a food source, you resort to something else. There's literally, they're starving and they're going to go after other things, and the balance comes about or changes. It's really cool to understand. So that was today, chapters 8 and 9. Friday, we'll get together for Yoga Quest at 7 a.m. PST, and shortly after, read chapters 10 and 11. I hope that you guys got some really nifty information as I read. I'm trying my best to read as clearly as possible and trying to pronunciate these things, but I'm just a simple gardener. I'm not a genius. I'm just a uh, an enthusiast, major enthusiast of the gardening and the soil and stuff. I always tell people that my experience so far has been with propagation, vegetative cycle, soil chemistry, and working the compost and having a lot of experience and being able to look back at the books and see these concepts in the field and stuff. It's really cool. Yeah. Sorry, I gotta mark that so I save it for later.